Good morning. Headlines for today's news bulletin are: researchers report new system to study chronic hepatitis B. Novel hydrogel developed for safer drug delivery. Scientists design nanoparticles attached with curcumin against cancer cells. A new discovery for treating heart attack. Moving on to the main news now. Researchers report new system to study chronic hepatitis B. Scientists from Princeton University have successfully tested a cell culture system that will allow researchers to perform laboratory-based studies of long-term hepatitis B virus infections. Researchers have so far failed to develop drugs that can cure chronic hepatitis B infections, partly because they have not been able to study the long-term infection of liver cells grown in the laboratory. At Princeton, researchers have tested a different system in which primary human liver cells are co-cultured with non-parenchymal stromal cells that support the function of the parenchymal liver cells. The researchers found that they could block hepatitis B infections in their co-culture system using drugs that either prevent the virus entry into liver cells or inhibit a viral enzyme that is essential for the virus replication. This platform thereby may aid the identification and testing of normal therapeutic regimen. Novel hydrogel developed for safer drug delivery. Drug-releasing devices that reside in the stomach for extended periods of time make it easier for patients to receive their full course of treatment. Instead of having to take a pill every day for a long period of time, a drug delivery vehicle that slowly releases individual doses of medication could be administered once but provide medication for weeks or months. Massachusetts Institute of Technology and the Koch Institute for Integrative Cancer Research have created a novel hydrogel material. The hydrogel is tough and triggerable, meaning it can withstand the forces of the gastrointestinal environment and can be triggered to dissolve using an external stimulus. This material represents one of the first examples of a triggerable tough hydrogel and could thus be used in many different applications, such as supporting stem cell growth in the lab or in medicine dealing with obesity. The next step in their research will be additional preclinical studies to further test the safety and stress resistance of the hydrogels before they can be used in people. Scientists design nanoparticles attached with curcumin against cancer cells. Attaching curcumin, a component of the common spice turmeric, to nanoparticles can be used to target and destroy treatment-resistant neuroblastoma tumor cells. The study, conducted in partnership by researchers at Nemours Children's Hospital and the University of Central Florida, demonstrates a potentially novel treatment for neuroblastoma, the most common cancer in infants. Curcumin has been shown to have substantial anti-cancer ability, but its low solubility and poor stability have made its use in medicinal applications very challenging. Researchers have found that nanoparticles can be used to deliver curcumin to tumor sites. Nanoscience research, which explores the unusual properties of materials at nanoscale, has definitely led to advancements in medicine, energy, information storage, computing, and other fields. A new discovery for treating heart attack. A new discovery by University of Bristol scientists helps to explain how cells which surround blood vessels called pericytes stimulate new blood vessels to grow, with the hormone leptin playing a key role. Leptin is produced by fat cells, which helps to regulate energy balance in the body by inhibiting the appetite. Importantly, the team found that pericytes produce 40 times more leptin when exposed to low levels of oxygen, and that this continued until oxygen levels returned to normal. This may help tissues to build more blood vessels to increase blood flow and oxygen supply. Together with other findings, the research shows that leptin has several important actions which encourage new blood vessel growth in areas where tissues are deprived of oxygen. Understanding more about the processes involved may help pave the way for development of new treatments for heart attacks, which could replace coronary bypass operations. Thank you.